Hello and welcome to section 1.5, which covers exploring angle pairs. So first thing we need to do is define some of these different angle pairs. The first one being adjacent angles. Those are two coplanar angles with a common side, a common vertex, and no common interior points. So vertex and sides that they share, adjacent angles. So if I have something like this, and we're just going to call this angle 1 and angle 2, that would be considered adjacent angles. They have a common side, being this one. They have a common vertex, which is here, and they have no common interior points. That means that inside of here does not share any points that are inside of there. So that would be adjacent. Adjacent also means right next to or connected to. Vertical angles, two angles whose sides are opposite rays. So these are two lines here. We could consider angle 1 and angle 3 vertical angles. Two angles whose sides are opposite rays. So the side of this one and the side of this would be opposite rays, as would this and this. They cross each other. They're going to make an X. They're going to share two lines. That's another way to look at it. This one right here and this one right here would also be considered vertical. In this case, vertical does not mean up and down. It basically means diagonal or across from. Complementary angles, two angles that add up to 90 degrees. They do not have to be connected to each other. They can be anywhere on the figure as long as they add up to 90 degrees. Supplementary angles, two angles that add up to 180 degrees. The same thing goes there. They do not have to be adjacent. They do not have to be connected. They just have to both add up to 90 degrees. Only two angles. Things that you can find on an unmarked diagram. So things that don't have the angles and things measured, the measurements on them. You can still figure out what would be an adjacent angle. You can see angles that would be connected to each other. You can see angles that are adjacent and supplementary, because if they make a straight line and they are beside each other, like this one up here that I drew, this one right here would be considered adjacent and supplementary because it makes a straight line, a straight angle. And vertical angles. You would be able to tell on this one right here that those are vertical without knowing what the degrees are, because they share the opposite rays. They share the lines. Things that you cannot find on an unmarked diagram. You can't tell if angles are congruent because you don't know what the exact measurements are. You can't tell if the segments are congruent unless you know the measurements. You can't tell if something is exactly a right angle unless it's marked. At complementary angles, you're not going to be able to tell that because you won't know if they add up to 90. So there are some things you can find without the markings and some things you will not be able to find. The next thing is linear pair. That is a pair of adjacent angles, so that means they're connected, whose non-common sides are opposite rays. So here is an example of this. And we'll just call this A. We'll call the vertex B, C, and D. So on here, angle ABC and CBD would be linear. So ABC, this one, and CBD would be a linear pair. Their non-common sides, which would be this one and this one, are opposite rays. They start at B and go the opposite direction. This side is the common side, but that's not an opposite ray because nothing goes down below B there. Postulate 1.9 is the linear pair postulate. If two angles form a linear pair, then they are supplementary. Okay, well that makes sense. If you would look at the drawing I just had there, those two would be supplementary. They make a straight line. So for my example, if I have angle ADB and BDG and I say that they're a linear pair, That also means automatically that they're supplementary, so keep that in mind. If the measure of angle ADB is 3x plus 14, and the measure of angle BDG is 5x minus 2, I want to know what are the angles. What is the measurement of ADB and measure of BDG? I can figure that out by knowing that when I add them together, 3x plus 14 plus 5x minus 2, they have to equal 180 degrees. How do I know that? Because they're supplementary. So I can go ahead and combine like terms, and it says 3x plus 5x, so that would be 8x. Remember, when we're combining, we always look at what's in front. We have a positive 14 and a minus 2, so I would be left with a plus 12 equals 180. And then I'm going to go ahead and get rid of my 12, leaving me with 8x equals 168. And I will divide by 8, and that will give me x equals 21. Then I have to actually go back in and check it. So is 3 times 21 plus 14, what is it? 3 times 21 is 63, plus 14 is 77 degrees. I also need to plug it into this second one here. So 5 times 21 minus 2. 5 times 21 is 105, minus 2 would be 103 degrees. 103 and 77 will add up to 180 degrees. So I have just checked my work to make sure that they're supplementary. An angle bisector. To bisect something means to cut in half. So it's a ray that divides an angle into two congruent angles, two equal pieces. So if I have a drawing here, something like this, and I'm going to say that K is here in the corner, this is J, M, and L. So if KM bisects JKL, the measure of JKL is 72. So the whole angle, this whole piece, is 72. What is the measure of JKM? Knowing that this piece right here is a bisector, all I would have to do is take 72 and divide it by 2, and I could figure out that the angle JKM is 36 degrees. If I know what bisect means, to cut in half, I can do that. So bring that knowledge with you, and I will see you tomorrow. Have a good night.